Ever encountered a blank payload or null pointer while processing a file? Or maybe an out of memory error while processing a huge file in Mule? Well, these are signs of bad utilization of streams. In this video, I'll try to explain about streams and how you can better utilize them to make your application efficient. So let's get started. Let's first understand what are streams. Let's take an example of collection. I have a database and this is my heap memory. So whenever I query the database using JDBC, I'll usually get a result set, and that result set will have all the data. Okay, and all that data will be loaded into the heap space. So if the data is small, it can be accommodated into an array list, and it will easily fit in the heap memory. But what if the data is huge and there is no space left in the heap memory? You'll land up with an out of memory error, right? So using a collections and loading it at once is not a good idea, as the payload or the response coming from the database can be massive. If it is small, it's good, there's no problem, but if it is huge, this approach is bad. So let's take the second approach, which is also called as pagination. What we do in pagination is we fit a set of records, maybe 1 to 10 in page 1, then page 2, 11 to 20, in this fashion. So pagination looks good. Again, I get the data, so it will be retrieved page by page, 1 page, 2 page, 3 page, and whole data can be loaded, and then you can process those pages and get rid of it from the memory. Like you receive page 1, you process it and give the response, and again you call for page 2, then give the response. So you do things in installments. Now assume if you get multiple requests at a time of the range of like maybe 100 or 50 requests at a time, and all of them start from the page 1. So now in this case the same problem occurs, right? All the requests will demand for the same page, and those pages will again get loaded into memory, and you'll get an out of memory error. So even pagination is having its own drawback. All of these techniques are still used. It's not that pagination is not used or collections are not used, they are still in practice, but also pagination is not again satisfying our demand. So then we have a concept of streams. Now let's understand what are streams. I have the same database, I have the same heap memory, and now let's understand how it will work. So when I query the database, I get something called as result set that we know, and what we can instead do is we can get a cursor to the database. Okay, and cursor is nothing but a pointer to any record in your database. So what happens in stream is you get a cursor, and that gets wrapped into an object which could be a stream. You also call it as iterator sometimes. So you get that stream, and then you can again wrap into another stream, or that is also called as chaining. You chain it into a stream. So in this case you get row by row instead of getting a huge record. So you get a row. When you are done processing that row, you demand for the next row, and so on. So here the data comes to you as and when needed, rather than coming all of a sudden. It is same as what you're doing right now. You're streaming this video, right? So in streams you get the data bit by bit, rather than the whole thing loading into your memory at once. You get the data, you process it, and then you ask for other data. So that's how it works. So let's understand what is chaining of streams. So the same example, only thing I have multiple streams over here. So I get a cursor, and then it gets wrapped into a stream. That stream has an ability to produce another stream object. That stream object can again create another stream, and you chain this object. So whenever, suppose this is the last stream object, and then you are doing some processing on it, so this stream object will return the data. Then when you need the another data, it will call the previous stream that created, then it goes back, and finally it reaches the cursor, and then you get another set of data. So this is how the chaining of stream works in practical scenarios. So it's the data is coming as and when required, rather than loading the whole thing at once and overwhelming the heap memory. So these are the basics of streams. So here are a few modules that support streaming. For example, the database has select operation, HTTP, file, FTP, SFTP, and Salesforce. So you can leverage streaming when using operations from these modules. Now let's understand what are the different streaming strategies available in Mule. So first is the non-repeatable stream. Then you have something called as repeatable, and repeatable has two types, that is in memory and a file store strategy. One more point to note is that stream objects are returned by HTTP modules, operations, and on new or updated file of FTP and SFTP module. Whereas iterable is returned by database, Salesforce, file, FTP, and SFTP. So for FTP and SFTP, only new or updated file return stream. Other than that, all other operation return iterable. Now let's understand each of this streaming strategy in detail. So what is a non-repeatable stream? As the name suggests, it is non-repeatable, but what exactly it means? Let's understand that. Consider a stream of river, and you and your friend have gone fishing in that river. You stand at a place, your friend stands at like maybe 200 meters apart from you, and you are the first person at the stream, and after that the stream reaches your friend, the river stream, and there is suppose one single fish floating in the river, and it comes to you and you catch it. Okay, so do you think that fish will reach to your friend? It won't, right? Because you already consumed the fish from the stream. So that is exactly what happens in non-repeatable stream. You consume the stream, and that stream is not available to the next processor. So you consider that you are a logger processor and your friend is a transform processor, and if you have enabled non-repeatable stream, so being a logger, you already consumed the stream, and that is no longer available for the transform stream. So you will end up with some null pointer exception if you try to do some operation on it, or maybe you might get a blank data when you write it to file, something like this. So that is what a non-repeatable stream or an iterable is. So you can read it only once, and it is also memory efficient. Why? Because you just do not store it memory for a long. You just read it and get rid of it. So you can use non-repeatable stream when you want to use the data only once and not multiple times. If you want to use the data again and again, like you are using two different file write operations at different locations, then in that case you might think of not using the non-repeatable stream. Otherwise you can go with a non-repeatable stream. That would help you a lot, give a good memory footprint. Next is the repeatable in-memory stream. As the name suggests, it is repeatable. You can read it more than once, and it is stored in the heap space, that is the memory of your Mule application. So let's see how does it work. Suppose you have a file and we are reading from that file. So basically when we read from a file, we get an input stream object, the Java basics. We get an input stream object, and what happens is this input stream object is buffered into some additional memory, or could be a variable or something. So it is buffered into that variable, and this whole thing is wrapped into an abstraction of streaming, which belongs to the org Mule runtime core internal streaming. So this could be your managed, cursor, iterator, or some other streaming class that are present in the streaming package of Mule. So you have the input stream object, then you have the buffer which loads the data, and then the data is provided to the next processor. So what exactly is the role of this buffer? Suppose you read a line of file and that gets stored in the buffer, and from buffer it is available to the stream, and then the stream provides the data to transform. This is how the flow works. Okay, and then in buffer you have an increment size and a max size. So this is how the configuration looks. So let's understand the configuration. Suppose you have initial buffer size as 256 KB. What it means is the initial size of this buffer can hold a data of only 256 KB, an input stream of 256 KB. Then you have an option to increase the buffer size. Suppose you realize that the data is more, so you increase it by maybe 256 or any desired amount, and then you can also specify the max memory size. So max is the maximum size that buffer is allowed to hold. So here in this case it is 256 only, so only once the 256 size is filled up with all the data, it will throw an exception. So you can make it something like max as 1024, so you get an initial of 256. Then when the 256 is filled up, it increases by 256 again, and you get 512, and you are still below 1024. So you'll be able to accommodate 256 KB of data 4 times, and if it exceeds 1024, you'll get an exception. So use repeatable in-memory streams when you know your file size is less and it can be accommodated in your heap memory. So it could be around like 5 MB, 10 MB file. It's good to have in-memory repeatable stream. But if it is of the order of 1 GB, 800 MB, 900 MBs, or maybe even 100 MB, it's not a wise idea to go with repeatable in-memory stream. So once you have implemented use the repeatable in-memory stream, what will happen is the stream can be used by the transform, but the same stream can be used by any other component after the transform. So transform will be able to consume, but the next component will also be able to consume, because again it will start reading. This buffer will hold whole file. The whole file, when completely read, when it is within the maximum memory size range, it is completely loaded into this buffer. So this buffer value will be provided to this transform. Again it can be provided to next transform. So the whole file gets loaded into the buffer in this case. Okay, now let's move on to the repeatable file store stream, which is useful when you have huge files to process. So it's same as the in-memory repeatable stream. Sorry about this, it should be file store. This is file store. So it's same as it is present in memory. Only thing is we have a temporary persistence. A file .tmp file might be generated in this case, and you again have the same buffer. Here I have specified as 512, which is default. And one point to note that the streaming strategy by default is set to repeatable file store stream. And why is it so? Because if it is non-repeatable stream, you would land up with an error when you have any other component after this transform, because this transform will consume and you'll get an error. And that is exactly the error people face in Mule 3 applications, because it does not have repeatable stream. So they put someone reads the file, puts a logger in front of the file and prints the payload, and once the payload is printed, it's as good as being consumed, right? So when you try for the next transform, the value is lost from the stream and you are not able to get it. So by default we have repeatable stream. And why is it file store stream? Because Mule doesn't know what kind of file you are supposed to process, right? You can process a file as big as 1 GB or 2 GB. So if you use in memory, then it's bound to be out of memory easily. So to avoid such, because people do not go to this streaming strategy and configure them, so it's by default configured as repeatable file store stream to avoid any unwanted errors. So what is happening over here? The same thing. You get an input stream object, it's being loaded into the buffer, and your size is 512 KB. So once that 512 KB is filled up, and we still have some data coming out. So what happens is it gets persisted to the temporary file, and then you again have some place in the buffer to pull another set of data. Again it goes to the file temp and everything is persisted, and then you can, using this buffer again, you can get the value in transform. And if some other processor after transform needs it, same thing, it will hit the buffer and buffer will now use this file.temp. It won't use the file.txt anymore. So it's as good as creating a copy of the same file when using repeatable in memory stream. So this is how the file store stream. So this is how your file store stream can work. Now there are some consideration while using streams. Now what happens while some people read huge files? Suppose you are reading a file of size 1 GB and you are trying to do some transformation on that file, and to determine if that file is empty or not, people use size of function. If size of payload is greater than 0, then they will process it, otherwise reject it. But the problem with this function is file size of payload will scan through the whole file. It's as good as loading the whole file into the memory. And what happens due to this is the whole thing, even though you have streaming enabled, but it will store the whole data into memory to count how many rows that file has, what is the actual size, so that to maintain the count it has to keep the whole thing in memory. And again you will land up with size of payload even though you had streaming of file store repeatable enabled. So you should not use size of just after reading the file to check if it is empty or not. Instead you can use is empty, so that will prevent the out of memory error. The other thing is, some people, for them the sequence is important, like they read the file, do some transformation, and for them the sequence should be important. So what they do is, in this case they apply a transform component right after the file. Although we are getting a stream, but what the transform component will do, it will load the whole thing into memory because it modifies the data and keeps it in memory. So again the same thing happens, it keeps on loading in the memory, and again you might run out of memory when the transform is right after your file read. So in such scenarios it is advisable, if sequence is important, it is advisable put the transform into a for each loop and provide some batch size to the for each loop, and then in like 1000, 2000, and then add a file right after doing your transform, and again in the next you append the data to the same file. So in this case you will never run out of memory. Or if the sequence is not important, go ahead with the batch processing. The only problem with batch processing is that it will initially load the whole data into a persistent VM queue. So if it is on-premise machines, it is fine, but if it is on Cloud Hub, so it will leverage your Amazon SQS for loading. So once the load phase finish, so it's as good as loading the whole data into 1 GB data into some other persistent area, and then it again returns the data from there. So it's ideal to go with batch if sequence is not important, and if you still want the sequence, then you can go with for each, specify some batch size, and then persist the data to some file, so that you get rid of all the data that is collected in memory and flush it to some file, and then you are ready to consume the next stream. So these are a few points that you should keep in mind while using streams. A demo on streams using a Mule project. So I have a Mule project having a listener, and then I have a logger, not doing anything, just printing request received. Then I have a database. So the database is in memory H2 database, and it is having like 6 rows in it. And what I'll do is I'll get the values from the database and I'll just print a raw payload. So this raw payload will possibly show me the object name, like from the streaming package, maybe a managed cursor iterator or consumer iterator, something like that. Then I'll apply an output directive of application JSON, and I'll get an application JSON data. Then again I'm trying to print the payload, and then I'm again trying to make it as application JSON. So why am I trying the second time is because I'll be using a non-repeatable stream, and to demonstrate that here we are not going to get any value, I've added this two other loggers after this logger. So initially let's try out with a non-repeatable stream. So we can go to the advanced tab, and in streaming strategy you can select as non-repeatable iterable. So it's iterable in case of select. If it was file, we would have a repeatable stream. If I go to this file and advanced, I can see it is stream, right? Non-repeatable stream, whereas in database select it is an iterable. So now let's deploy this application and let's see what the output is. So the application has started and I have already triggered a request. So if we observe the logs, I get the first logger as request received. This logger, I've got the value as request received, and the second logger which prints the raw payload after select. So ideally it should get an iterable stream, right? So that is what we are getting. We are getting a streaming from streaming package. We are getting iterator, and that iterator is consumer streaming iterator. So this is the object that is getting printed. This could be an object location in the memory which is getting printed, but this is not the actual data. So the stream or the iterable was not yet consumed. So in the next logger it is still available. You might be wondering that I have already printed the logger, but why is it still available in this? Because I haven't consumed the stream yet. It's printed as is the object, not the content of the object, right? So in next step, what I've done, I've added an output application JSON directive, which is effectively transforming that data into a JSON. That stream or iterable is being transformed into a JSON, due to which it is effectively getting consumed. So I can see the JSON and name and ID, and I get all the 6 rows present in database. So again I have the next logger which prints raw payload. So again we'll get the object type which should be the consumer streaming iterator, right? So we are getting the object printed. But in the next step, when we try to actually get the content of that object by adding an output directive of application JSON, we are not able to see the value, right? It's a blank array. Why? Because it was already consumed by the previous processor, which was JSON payload logger, right? Now, so that we, in this case, we understood that the non-repeatable stream once read cannot be read the second time. Now what we can do is, now we can change the streaming strategy, and what we'll do, we'll change it to repeatable, repeatable in memory iterable. So if we see, it is slightly different from the slides that we saw. In the slides that we saw, it was not max memory in memory instances, instead it was something like this, right? If I go to read and I go to advanced streaming strategy, so it is max in memory size, but in case of select it is max in memory objects. So the total instances that we are allowed to keep has to be defined. So if it becomes more than 500 instances, then it will give an error. Initial buffer is 100, then if 100 gets filled up, the buffer variable gets filled up with 100 instances, it will again add 100, again add 100, and this can happen for the next 4 times after the initialization of 100, and once it reaches 500 objects, it will throw an error. So this is the repeatable in memory iterable. Now let's try to run the application using the repeatable in memory iterable and see what's the output. So remember, keep in mind as of now that we get consumer streaming iterator, and this will change in the next run because we have used the in memory repeatable stream. So let's redeploy this application and let's try to hit it again. So I've triggered it again, and let's see what do we have now. Request received, and observe that we are getting a managed cursor iterator provider as opposed to consumer iterator, right? So the object has changed, the streaming object has changed when we use in-memory repeatable store, and we get the same output. We are able to get the data back, and again in the second logger also it is able to consume the stream because it was in memory and it was repeatable, so we were able to consume it 2 times. Now we are getting this error, attempted to send invalid data through HTTP response. It is occurring because we do not have any transform, right? And what we are effectively returning is a stream object as it is to the HTTP response, and that is why, and since stream object is being returned, it is throwing an error that okay, you are not allowed to send a stream object. So instead, if we add a transform over here, this error will go away. And why did this error not come in that non-repeatable stream? Because the stream was already consumed, so there was nothing in the stream, and that is why we didn't get such error. But now the stream is still present because it is repeatable in this case. So keep in mind that the object will change, it will become managed cursor iterator. So this is the observation that we can have, and the stream is still present, and this is inside the heap memory. The whole data is loaded inside the heap memory. Now let's change this to file store repeatable stream, repeatable file store stream. So we see that we now only have one configuration, that is in memory object. So only 500 objects should be allowed in memory. If it exceeds that, then it will persist to a file store inside the Mule runtime. So let's save it and redeploy the application and see what changes can we observe now. So I've triggered the request again after redeploying the application. This time it is with file store repeatable stream, so it's not in memory. And let's see the logs. So we observe that the object is same, the object doesn't change, it only changes when it is non-repeatable stream. When it is in memory repeatable or file store repeatable, it's always managed cursor iterator provider, which belongs to the streaming package of Mule runtime core. And we get the data with all the 6 rows, and again we are able to get the data in the second log. And this error is obvious because we are trying to send a stream which is not valid. Instead we need to add a transform and change it to output application JSON, and that will solve this problem. So in this case we are returning stream, and that is why we are getting the error. So similarly you can try out with SFTP connector, FTP connector, file connectors like read in this case, and try out different combination and see how the behavior is. One thing which I was telling in the previous slide, suppose if this file is reading a huge file, right, like of the order 1 GB, and you have to maintain the sequence. So what I was saying that when you want to check the size, if it is empty, only then if it is not empty, only then you should process. So what you can do effectively is like add a choice, and here instead of adding size of payload, just simply add is empty and your payload. So if it is empty, it will not proceed. If it is not empty, only then it will proceed. You can do something like that. And then if sequence is important, put a for each loop, and then inside that for each loop you can add a batch size, like maybe 1000 records at a time, or maybe 500 records at a time, something like this. Add that, and you can do whatever transform you want to do. Just add a transform. But in case if this transform is added over here and this file is very huge, it has CSV, it is a CSV file of maybe millions of records, then this transform will cause the whole thing to load in memory, and despite of having streams enabled, you will get an error. Or even in case if this is instead of is empty, if it is size off, and this transform still remains inside, and if it is size off, it still loads everything into heap memory because it has to count the size, whereas is empty does not need to count the size, it just checks if it is empty or not. And then you can add your file write with something like, okay, file write, and you might want to append the data to the file, right? Instead of creating new file, you can just append with the write mode append. So this can solve your problem of reading a huge file and also maintaining the sequence without facing any out of memory error. So do try this out with some huge file. As of now I don't have any huge file to test this out, and also my machine is low on RAM, so it will take long time. But you can definitely try this out and try various combination, try out with Salesforce, try out with database, select multiple combinations. You can test that. So I hope you might have found this video useful. Thanks for watching.